Okay, so today we're continuing on Module 12.4, Similarity in Right Triangles. And again, still the same objective. Students will use similar right triangles to discover the proportional sides. So first, I'm going to do a little bit review of Pythagorean theorem. So in example 1, we want to solve for side AB. So if I use Pythagorean theorem right here, this Pythagorean theorem is a squared plus b squared equals c squared. And remember, this is your C, this is A, and actually this would call this B, and this would be A. Okay, so for A, you know that's going to be 2 squared. A, again, is 2 squared equals C squared. So 2 squared is 4. 2 squared is another 4. So here you get 4 plus 4 is 8. 8 equals C squared. And you want to get rid of the square, we square root it. Okay, so here I get square root of 8 equals C. But I want to reduce this, so I know I have C equals square root of 8. But 8, same thing as saying 4 times 2. So here C would equal square root of 4 is 2. And the square root of 2, you can't reduce that. So here I'm going to say that C equals 2 square root of 2. Or side AB is 2 square root of 2. All right, example 2, I want to solve for side AC. So again, here, this is A, B, and then C. Okay, so my Pythagorean theorem is A squared plus B squared equals C squared. A right here is 1. B squared, I don't know what it is, so I'm going to leave it as B squared. C here is 2. So 1 squared is 1 plus B squared. 2 squared is 4. So I'm just going to subtract 1. These eliminate. I get B squared equals 4 minus 1 is 3. Take the square root of it. So I get here B equals square root of 3. Or I'm going to say actually side AC is equal to the square root of 3. Example 3, AC. Oh, okay, sorry. Made a typo right here. Change this to AB. That's the side that's missing. So again, remember this is A, B, and C. So again, A squared plus B squared equals C squared. So here I have 3 squared plus 5 squared equals C squared. So again, 3 squared here is 9 plus 25 equals C squared. So I just add 9 and 25. That gives me 34. So I get 34 equals C squared. And I take the square root of both sides. So here C is equal to square root of 34. And 34 cannot be reduced. No, so my answer will leave it as a square root. So I'm going to say side AB is equal to square root of 34. All right, so next part says write the similarity statements for the 3 triangles. So again, always start off by writing out your 3 triangles. And you always want to put the 90-degree all in the same direction. Just to make it easier to understand how they're similar. Okay, so I'm going to start off with this small triangle there. So I have DB down here, and then C up here. Okay. And then my medium triangle here. So this side right here, 90. So this is D, and I have C, and I have angle A up here. Okay, and then my big triangle is, remember, it's the whole triangle here. So there's a 90, it's at C, B, and then A. Now my similar sides I want to write out. So I'm going to say CB is similar to AC, similar to AB. So that means these sides are all three are similar to each other. Then also say next side. So I'm going to say CD similar to AD, similar to AC. And then the last one, so I'm going to start with DB, similar to DC, similar to CB. All right, so those are all the sides that are similar to each other. All right, next one. Again, start with 3 triangles. And let me start with the small triangle right here. So there's my 90, H in the corner, C, and A. All right, next one, the medium size. 90 is right here, H, A, and then B up here. And then my big triangle. So there's the 90. So there's A, C, and then B. All right, so just mark the similar sides here so we know these 3 sides are similar. Okay, these 3 sides are similar, which means the last 3 sides are also similar to each other. So that means that this side, okay, so 3, 3, and 3. All right, so those are all the sides that are similar to each other. All right, example 6, you want to complete this proportion. Okay, so again, let's create our triangles here so you can know what goes where. Okay, so let me start with the small triangle here. So I put my 90, this is D, B, and C. Now I got my medium triangle, D, C, and A. And then my big triangle, 90 degrees at C, B, and then A. All right, so now let's look at the proportion they give us and let's find the missing part. So here's CD. Let me look at which triangles have a CD. So there's this one right here and this one right here. Okay. And let's look at the next one. DB is right here. And then AD is right here. Okay, so what we notice here is that we're using this triangle and this triangle, have these sides. So that means that the question mark here is going to be, because you see we have CD, DB, you have AD, and then DC. So right here, we put DC. Example 7. Just again, set up our 3 triangles. So small one, again, D, B, C. Medium one is at D, C, A. And then large one is at C, B, and A. So let's look at the 2 triangles that have these together. So start off with AB. AB is right here. Okay, there's no other triangle in AB, so let's stop there. Okay, and then let's look at AC right here. So AC right there is right here and right here. Okay, which means that the last one, AD, is right here. Right, so that means that if I look at the sides correspond, remember this one, let me make a different color. Okay, so this side is similar to this side. So, and then this side is similar to that side. Okay, so these 2 go together. So AD and AC go together. And also AB and AC go together, right? So what we're missing right here is I have AB and AC, AB, AC, and I need AD and AC. So right here, we will put in AC. Okay. Number 8. Let's here, CAB. The triangle CAB, BH equals to 5. So B to H, this is 5. Okay. And CH is 3. And so what is the length of HA? So HA is right here. So the way we solve this is we set up a proportion like this. We say 3 over HA equals HA over 5. And then we just cross multiply right here. So we say HA squared equals 3 times 5, which is 15. And I just take the square root. So here I say HA is equal to the square root of 15. Okay. Number 9. In triangle ABC, it says AD is 7. So this is 7. DB is 3. So 7 and then 3. This is what is the length of CD. So CD is right here, which we don't know what that is. So again, we start off by writing it down. 7 over CD is equal to CD over 3. And again, cross multiply. CD squared equals 7 times 3 is 21. And I take the square root of both sides. So I say here CD is equal to square root of 21. And last one, number 10. In the triangle XYZ, we say XW is 5. So this is 5. WC is 7. Asking what is the length of YW? So we don't know what that is. So I'm going to start off by writing out 5 over YW equals YW over 7. And I cross multiply. I get YW squared equals 5 times 3 is 35. Sorry, 7 times 5, 35. And I take the square root of it. So here I get YW equals square root of 35. Okay, so we're done with today's notes.